Alright, here's some important notes I wanted to highlight for day 10. And so, looking at 3.8, I believe, I skipped a few of the first examples. But here in problem 3, it says write an equation in slope-intercept form, so that means y equals mx plus b. I just wanted to highlight, you got to solve for y, right? If it's parallel, that means it's the same slope. So it's helpful to solve for y, to put it into y equals mx plus b form to figure out what the slope is, okay? So since the slope is 2, it goes through the point negative 5, 8. You can write it in point slope form first, right, like this. Y minus 8 equals 2 times x plus 5, right? The signs switch. And since it asks for slope-intercept form, you got to distribute the 2 and add the 8, so 2x plus 18, okay? Here, when we talk about perpendicular lines, I wanted to highlight here. Remember, slopes are perpendicular if they are opposite and reciprocals, right? Opposite meaning one positive, one negative, and reciprocals meaning the fractions are flipped, right? One way to think about it is here the product of the slope is equal to negative 1, okay? So I just wanted to highlight that, all right? And here just a quick example, all right? Just wanted to draw your attention to a couple things. What's the equation of a line perpendicular to this line? Y equals 2/5 x plus 1. And through the point negative 3, comma 4. Okay. So you are going to be asked to show work. All right. If you know the original slope is 2/5, that means the perpendicular slope is going to be negative 5/2. Right? Remember opposite, and you flip it. Okay. And then through the point negative 3, comma 4. So you substitute those values in. Okay. And then if you want to change it to slope-intercept, you can do that as well. In part 2 of 3.8, in the beginning here, it says without graphing, tell whether the lines are parallel, perpendicular, or neither. And a lot of this, and it seems like tedious work, it's going to be most beneficial, right, to solve for y equals mx plus b so that you can easily tell the slope values, right? If they're not the same, then clearly it's not parallel. These are opposites, one positive, one negative, but they're not reciprocal, so neither, okay? Number 2, okay, these slopes are perpendicular. And then for number 3, the slopes are the same, so they are parallel. This one here, again, just kind of, going over the work carefully. Sometimes it helps to solve for y, right? Kind of like what we did a couple slides ago. And then for a perpendicular slope, okay, you got to first figure out what the original slope is. So since this one is 3/5, then the perpendicular slope is negative 5/3. Okay. Don't forget to use negative 5/3 in your final equation, right? So many students go back and use the original slope, right? If you use the original slope, then that makes it parallel, okay? And then here, what I wanted to highlight was numbers 16 and 17. All right, x equals 4 is a vertical line. When it's x equals, it's a vertical line, and so that means you go 4 to the right on the x-axis, and it's a vertical line through that 4. And then y equals negative 2 means you go down 2 from 0, 0, and it's a horizontal line. Okay, so x equals is a vertical line, and y equals is a horizontal line. And then moving on to simplifying radicals. This is something you should have gone over at the end of Algebra 1. Okay. You're looking for numbers or pairs of numbers where one of them, at least one of them, is a perfect square number. So like here, the square root of 45, you're going to use 9 and 5 because the square root of 9 is 3, right? 5 is not a perfect square number, and so you just leave it, square root of 5, okay? So like here, for 2 square root of 18, we used 9 and 2 because the square root of 9, again, is 3. Now, you can say, well, 6 times 3 is 18, right? But 6 and 3, neither of those are perfect squares, so you can't break it down. Okay, so it's about using numbers, perfect square numbers, which are listed up here. Okay, and so we're going to start getting into simplifying radicals in a little bit, and so we wanted to highlight that here. Okay, and then as we go into 7.1, looking at ratios and proportions. This is going to be kind of important as we look at some more triangles and properties of triangles and things like that. All right, but just kind of an introductory lesson for 7.1. Right, a ratio is a comparison of two quantities by division. Okay, the units must be the same. Hopefully that's obvious. 3 ways to express a ratio, right? You have a colon, right? You can write the word to, T-O. Most commonly, it's going to be a fraction. And I want to highlight here on the left, it says always convert to the smaller unit, okay? And so here, in this example, you're comparing a scale model of a car from inches to feet, right? And so 4 inches to 15 feet, well, that doesn't make sense, right? So you got to convert one of them. So we're going to convert the 15 feet and make it 180 inches. Okay, don't forget there are 12 inches in a foot. All right, so now we can, correctly compare these units. Okay, so 4 inches to 180 inches, it's 1 over 45, that's the ratio. Right? Meaning this car is 45 times bigger than the scale model. Or you can say that the model car is 45 times smaller than the actual car. Okay. And a proportion is when two ratios equal each other, right? Let me go back here. So a ratio is just one fraction. A proportion is two equal fractions. Okay, now you've got a proportion. All right. And you should have done some of these or some types of problems like these. When you solve a proportion, we're going to use what's called cross multiplication, right? And we set them equal to each other. So 7 times x is equal to 5 times 12. I kind of skipped over this, right? You have the means and extremes, okay? And then you work that out. And number 6, you have 4 times the quantity y plus 3, so that's why you need parentheses, is equal to the other diagonal multiplied 8 times y. And then just some properties of proportions here. Okay, these are all equivalent. All right, so go over these properties here. Okay, and that's it. All right. If you have questions, please let me know. Okay. If you need to rewatch this video, especially for 7.1, since you got to take a quiz today, that's fine. You can do that. All right. So again, let me know if you have questions.